All right, so let's look at the rest of what we're going to talk about with least squares regression. We talked about what a residual is, and there's something else we're going to look at, which is a residual plot. And that is just where we take all of the residuals and make them a scatter plot. And what this tells us is whether or not a linear model, which would be our least squares regression line, is actually a good model for the data. All right. And the way we tell is if we look at the residuals and they have some sort of curved pattern, then a linear model is not the one to choose. So here we have the residuals, and they usually put a line just to kind of give you the pattern of the residual. So these residual plots both have clear curved patterns. So that means that we would not use a linear model for whatever this data is. Okay, so this is the residual plot for our truck data. Okay, and so like this point means this car at I don't know, 15 miles driven, the residual was positive. So the predicted value was lower than the actual value. Okay, and so that's what each of these points is. All right. Um, the questions that you're going to be asked a lot about residual plots is, would this linear model be a good fit for that truck data? And the answer is yes, because my residuals do not have any sort of curved pattern. They're just kind of all over the place. All right, and so once we have established that a linear model is good, now we have to see like how good is our linear model. So we have the right shape. How good is our line at actually predicting what's going to happen with this data? And so there's two numbers that we're going to look at. One is the standard deviation of the residuals. Okay, and so this is your regular standard deviation formula. Okay, so we're measuring with that the typical size of a residual. Okay, so kind of like overall, how far are our actual data points from the predicted line? Okay, the second number is called the coefficient of determination, and that's given by r squared. It is actually the correlation value, that r value that we talked about before. It is that number squared. This is how it's calculated. Again, wouldn't worry about the calculation part, more of can you interpret it. And so what r squared is the percent of variability that is accounted for by the least squares regression line. In other words, so with this truck data, what percent of the change in price can be accounted for by the change in miles driven? That is what r squared is equal to. All right. And so again, we have to be able to interpret these two values. Finding them is not really a thing, but you got to be able to interpret them. Okay. And so here are our sort of template sentences. Okay. So the standard deviation of the residuals. This sentence is very typical of what we've done with standard deviation before. So it's the actual, whatever we're talking about, is typically about blank away from the value predicted by the line, the least squares regression line. All right, and then for coefficient of determination, or r squared, we're saying how much of the variation. Okay, so for our truck data, okay, S is 57.40. So the actual price of a truck is typically about 57.40 away from the price predicted by the least squares regression line. And then r squared. So our r squared is 0.66, which means about 66% of the variability in the price is accounted for by the line with x equals miles driven. All right. Like I said, finding these things is not going to be really a thing. It's more about interpreting them. And so a lot of times what they'll do is they'll give you some computer output. So this is from statistical software called Minitab. All right. And you might see something maybe that looks slightly different from another computer program. But the biggest thing is, can you find somewhere in this computer output, can you find these things? Okay, can you identify which of these numbers is the slope? What's the y-intercept? What's S, the standard deviation of the residuals? Where's r squared? And can we find r? Okay, for the most part, these numbers, standard deviation, T and P, for the most part can be ignored. We might talk about T and P a little bit later, but really we're looking at these coefficients. Okay, constant is the same as y-intercept, and then this would be my slope. So here's my y-intercept, here's my slope. All right, S is clearly labeled S, R squared is labeled R squared. And then if I want the correlation R, it is going to be the square root of my R squared. So if they give it to you as a percent, put it as a decimal. All right, and so the R, the correlation for my truck data would be 0.845. Okay. All right, so we're gonna look at an example. Here is the data, both the scatter plot with regression line and the residual plot. And then we also have some computer data here. And so you are going to answer these questions that pop up.